that if we are not taking up physics as a career, or if you're not majoring physics to become an engineer or a cosmologist or who will deal with physics and become a physics teacher, physics is not my cup of tea. I won't learn physics because neither I'm a physics teacher nor I'm getting into astrophysics. I'm not into engineering or not into data science, so I should not learn physics. But that is a very wrong conception. Physics is something which every human being or every educated person up to some level should learn, because it is not career, not money, not engineering, not nuclear physics, but there are other things which makes you better as a human being, better in terms of critical thinking, better in terms of enriching your mind power and many other things. In this video, I am going to take you through a journey which is totally different from the usual convention of learning physics and taking up physics as a career, and coming out of the misconception that if I'm not majoring in physics or if physics is not my career in the near future, I should not learn physics. In this video, I'm going to talk about certain essential aspects of physics which every human being or every person should know, not to take up physics as a career, but in order to enrich yourself in terms of thinking, patterns, and various other things. My name is Shaunak. You're watching this video on my channel, Physics for Students. So the first thing that you saw right on your screen is something which is very, very important. You learn a new method of thinking. Now, what do I mean by new method? First of all, you need to understand that physics is basically how nature works, right? From the dawn of human civilization, we human beings always wondered why the sky is blue, why things fall, or why apples fall, why things moves in motion, various other things in which how the world moves, right? So whenever we are thinking that how nature works, that means we are trying to understand the laws of nature in terms of certain fundamental things. So first thing, that you learn a new model or a new mode of thinking means it is not a linear way in which you think how things work. So physics helps you into what we call a non-linear way of thinking. What do I mean by non-linear way of thinking? Okay, this is not the right way to compare, but still I would like to take mathematics and physics right now. So when you deal particularly with a mathematical problem, it will be algebra, abstract algebra, calculus, complex equations, whatever. Generally what happens is that you think the mathematical problem only in its own term. Right, I hope I can make you understand. Mathematical problems deals only with the mathematics. But when you start learning or when you start dealing with problems in physics, there are a lot of things which you take into account. Say for example, when Newton thought that why the apple falls, it might have been that he would have thought for something else. Something that might be that the tree was not being able to hold the weight of the apple, it falls, or maybe the vacuum under the place where he was thinking, the air vacuum has lost and just fall down. So various other things. So what I'm trying to mean is that when you think of a problem in terms of physics, then you take into account a lot of things. You take into account the electricity, the magnetism, the volume, the weight, the momentum, position, lot of other things. Now, I being a maths major, I mean to say, I should not say this, but in general, when mathematics, you're dealing with a complex problem or hyperbolic, then you think only in terms of mathematics. There are not physical things which really perturbs or disturbs that system. So first thing is that you need to take into account many parameters. For example, a water flow, for example, electricity, for example, magnetism, or whatsoever. So this is a totally new method of thinking which is not linear, which is not just you take the mathematical part and go and move into the variables and algebra. No, you have to take into account how the entire nature behaves, how the wind flow is there, how the current is there, the weather is there, the humidity is there, lot of A, B, C, D, X factors. Physics inculcates within you a new habit or a new method of thinking. What this new method is that it is not a linear method, it is not a linear way. You have to take into account force, momentum, position, spin, and whatnot. So when you are learning physics, remember that this is a new method of thinking, and this new method of thinking will come into play into various ways. For example, very recently we had our meeting in our from our college, and some of the courses or some of the things were not going well right now. So the CEO or the board of directors have to take into account many things. We cannot just draw a conclusion, okay, STEM is not working, this is not working. No. So we have to take into account the current economic scenario, the post-pandemic scenario, the manpower that is working, what are the mental conditions of the manpower, are they right in a position to do, what is the sales that is happening, what are the university rules that have taken place. So you see parameters are taken into account. Then you can come not just one and you come to a conclusion. So point number one, physics helps you and it teaches you in a new method of thinking. Okay, the second thing which is coming up is called you learn an observation and deduction. I would like to quote the famous quotation which Arthur Conan Doyle used in his famous world-renowned character Sherlock Holmes. In this short story called Boscombe Valley Mystery, he says to Watson, "You know my method. It is found upon the observation of trifles." It is found on the observation of trifles, means mundane things, very simple things. So Sherlock Holmes used to make observations on certain trifles, some very rudimentary things, and then he used to draw a conclusion. Physics is exactly about that. So you learn observation and deduction. You try to observe a lot of things around the nature, which helps you, which teaches you a new way of learning things. So when you observe certain things, for example, physics is all about studying nature. So it is about the wind, the air, the gravity, the force, the magnetism, and all those things. Then what you learn is that you develop a kind of an observation skill. And from that observation, you generally find to try a deduction, which can be a scientific method. Now this observation and deduction can be used not only in physics, it can be also used in finance, in data handling, in weather forecasting, in data mining, in artificial intelligence, in deep learning also. Because you are now learning a new method which is data handling, and this it is about observation, and this observation is not only restricted to electricity, magnetism, or about nature. You learn the method of doing those observations in a certain way that in other parts of the industry also. You go as a finance, as a chartered accountant, into business industry, as a principal, as a teacher. This habit helps you to finally conclude involves a lot of logical and critical thinking, and that is being done when you learn physics. So you see, what I'm trying to make a point is physics is not all about relativity and Newtonian mechanics. No, it involves and gives you a new method of learning, which inculcates a new habit, which helps you to learn or make decisions correctly. So observation and then the deduction, and these observation, because as I told you, takes into account a lot of parameters. So that observation has to be very keen, have to be very clear, and then you can come out, or then you can find a proper deduction. So this moving around the things, how the world really goes around, is basic essence of learning physics. I think that for every human being, I remember the famous Richard P. Feynman. He describes in his early childhood how his father used to describe how things happen, why the bird is singing on or perching on a particular tree, and everything, small details about how nature moves around. So I think that yes, it is very important for all of us human beings, and it is a natural curiosity for all of us to understand why this is so, why this is so, and that is what physics teaches. It teaches how things moves around, and it satisfies the natural curiosity of every human mind. So yes, that is very important. Learn how the way world moves around, because physics, right from the dawn of civilization, as I was talking, is all about how things really move, how things really fall, how things really stand, how things really happen. So how you learn to solve, practical problems. Now, when I use the word practical, you might think that is it that mathematics does not teach you to solve practical problems? No, I'm not saying that. But what happens is that mathematics, if you go deep into mathematics, it is more about abstraction. You take algebra, you take group theory, you take knot theory. These are all very abstract, and when you go through those things, you really, I'm saying pure mathematics, you really do not have anything practical which comes really in front of you. Let me take you an example. For example, there is a concept which is called a Calabi-Yau manifold, which I discussed recently in one of my videos in string theory. It teaches about multiple dimensions, 9, 10, and so. Now, Calabi-Yau manifold is a kind of a concept which is developed by Calabi and Yau, and which is a part of pure mathematics. But Calabi-Yau manifold was there until the string theorists really made a use of Calabi-Yau manifold in order to understand and sort out the dimensions which we generally learn in physics for string theory. Now you see that solving practical problems, that means Calabi-Yau manifold won't have any use until it is being practically solved, which the string theorists are doing. So considering a lot of other, it just came into my mind, there are a lot of other things which the mathematicians, they generally develop, and it is not being used until physics come into play. So yes, you really learn to solve practical problems starting from pure mathematics, then you go into engineering, thermodynamics, fluid dynamics, a lot of things. Lot of practical problems are being solved, and this is something essential, because only with abstract problems things really do not move around. And then again, by learning how to solve practical problems, you not only score good marks in your physics grad or physics major, but you can take that into other aspects of your life. It can be finance, it can be mathematics, it can be statistics, and it can be even an entrepreneurship. I see young people around, those who have become principals or professors of mathematics, they are really lacking this practical problem solving capacity. They really don't know when a decision making comes, when a particular problem in the university crops up, they really have no idea, I'm sorry to tell, that how to solve this. Now, it is not that all physics grad or majors would have a great idea, but yes, physics do help in solving mathematical problems. So when you join in a university or a college coming from a different background, maybe arts, maybe commerce, or maybe anything, then you really have not solved those mathematical or practical problems. So when it comes to taking a decision right in a university as a chancellor or with the senior teachers, I have seen that they really lack that. And that is why the practical problem solving ability is not being practiced either in their childhood or in the later career of life. So yes, this is very important that it helps you to solve practical problems. Okay, so what do I mean by abstraction turns into reality? I just mentioned one concept which is called Calabi-Yau manifold, where the abstraction of mathematics are now taken into use into practical problems. Most of the people who are taking up mathematics as a major, whether it is practical or applied, pure or applied, particularly for pure, really don't have any vision. They give up mathematics after a certain semester. They feel mathematics is not their cup of tea. They feel they generally go into banking, finance, or any other institution, leaving apart mathematics. The real reason is that they really don't see any practical use, and that is true. I made a separate one or two videos in whether you should take up pure mathematics as your career or not. Well, that is a different issue. What I'm trying to make a point is that abstraction of mathematics, group theory, ring theory, topology, differential geometry, all this comes into use into reality when you take up physics. I'm not going to elaborate because you know that physicists approach a problem in a totally different way. We talked about practical problems. We talked about a new method of thinking of logic and deduction. What happens is that all those abstract concepts of mathematics, which seems to be, oh, these are nothing, we really cannot see anything, we visualize, comes into practical use when you are solving physics problems with those mathematics. So yes, if you're really thinking that mathematics and abstract concept, what it will become, how will it come to use, physics is the answer. Again, this video is not meant for those who are already taking up or This video is basically meant for those who are thinking that if I do learn certain abstract concepts, not only in mathematics, there are a lot of abstract concepts in other areas of other areas also, then you can directly use that concept into practical use. Right. See, for example, around 6-7 years back when I learned Arabic from Ramakrishna Mission, I really thought that Arabic won't come to use. It is all abstract. But right in my college, when I see a lot of students from Saudi Arabia coming in, a lot of mark sheets coming in, and the administration is really lacking that what is written in the in the mark sheet, whether they're a graduate, non-graduate, which University of Egypt or Cairo they have graduated. I can help them. I can help them decode the mark sheet, and I can help them to learn that this is so. Why? Now you see the abstract concept of Arabic is now coming to use. Similarly, in your life, there are many things which you have learned, which you think that these are not coming to use. But I will tell you, these things will come into use, into practicality, once you start learning physics and implementing those abstract concepts. So physics is all about questioning, right? So you question why the sky is, so question why things are that, this, electricity, and all those things. So the art of questioning is really something very important, and questioning until you find the fundamental answer, until you find the fundamental particle. So yes, I mean to say, physics teaches you how to question. I remember in a meeting with great Professor Amol Kumar Chaudhary, when there was a question that, sir, what is the difference between the students in India and that of Cambridge? So Professor told that, although I am not biased, that the students in India really don't question. When they tell you that Einstein was right, they take it, okay, Einstein was right. But in Cambridge or in the overseas, the students question, was Einstein right? Do you think that this equation of Einstein is really okay to go ahead or not? So the art of questioning, the fundamental courage in order to question an authority is something which physics teaches you. Because until and unless you question a particular equation, the forces of nature, the way things happen, you are not learning physics. I am not comparing again, yes, mathematics also helps you questioning, but it is more in physics, because physics deals about nature. Physics deals about why we are talking. Physics deals about why this mobile is on. Physics deals about how this mic is working while I'm talking. Doesn't really deal much with the art of questioning. The fundamental question, why, and why, this is something which physics does. And you go deep until you get the proper answer. And you keep on questioning your professor, teacher, mentor, and anybody that, sir or ma'am, tell me why it is so. So physics has got a fundamental capacity of questioning authorities, questioning how things work. And you know that Einstein told that I'm just like you, but I am tremendously curious. I'm not sure whether it was Einstein or Hawking. Sorry for the mistake. But yes, it is questioning, and questioning the fundamental things and going deep root until we get the answer. Well, this particular point is something which is really losing their relevance in today's world. You learn the historical evolution of thoughts. Physics is not all about mathematics, the way, the gravity and other things. But if you see how the human evolution of thought began, then definitely it is all about physics. I'm planning to make certain very good videos on the evolution of human thought related to manifolds, functions, and other things. And I'm sure that you're going to enjoy. The basic idea is that when you go through physics right from the day of the Greeks till today's string theory or M theory or anything, then you learn how human beings have how human beings have started to learn, how human beings have started to think, and what are those things which really matters. For example, when I am making a detailed research on maybe topology or differential geometry, really I go deep, and I found very less amount of works, data, research work. So I questioned my professor that, sir, why it is so? He told me that, Shaunak, how long is topology? How many years differential geometry has been in work, right? But considered to Newtonian mechanics or relativity, you see how many years it has evolved. That means human evolution, human thought, as more it gets, we get more theories, more research, more data. right? So it is learning through this. Then you learn, okay, so if I am doing a research on a very recent topic, I will get less data, less information, there are less amount of people whom I can really go and talk. But if I'm dealing with certain things which are quite old, classical mechanics or relativistic physics, then I'm going to get more data, more people. This is a learning which tells you that how human evolution has evolved. If you go into physics, I think you get almost a huge timeline, a huge era in which human thought has developed, and that is how technology has developed, and that is how we develop, and the entire world moves around. So physics actually teaches you how the evolution of thought began, how human beings started to think, how the brain started to mature, and that is the result of today's technology that you are watching this video on YouTube. The last thing which is very, very important, that yes, you learn a lot about recent technological developments. Now why? Because physics is all about developments. As I told you that human evolution and thought, then physics is all about human evolution and thought. That means today we develop JWST telescope. We find out that there is the Bell's inequality theorem, the quantum entanglement, the quantum computing, the deep learning, the artificial intelligence, everything. So it is all about technological development, and once you learn physics and you really fall in love learning physics, what happens is that you learn and learn and learn a lot about the technological developments. Now you see, all these technological developments have taken place because humanity or human thought has evolved through time. So don't you think that physics is too fascinating for you? Taken all these points, it ultimately boils down to curiosity, how things work, how nature works, and most importantly, how the technological advancement takes. Physics really teaches you and keeps you abreast and right on the toes that what is the technological advancement which are taking place. Now, if you're not enjoying physics, definitely you would just learn for the sake of learning, but you won't go deep into the technological advancement. But every time I see NASA or anything, quantum computing has evolved and it has developed new machineries which will be definitely beneficial for human life, I get fascinated, and it is only possible because of physics. So that's it. I think that I won't make the video long. So I have covered, I think, most of the important concepts why you should take up physics, or I won't say take up, but you should learn physics up to a certain extent. Mind it that this video, again I am repeating, is not meant for those who are already into physics or who are taken up, because those who are already into physics or who have taken up physics as a grad program, you are already in the boat, right? You are already in the stream and you are flowing with the water. But this is something which you are not taking up, or you might think, no, physics is something which is related to science, mathematics and analytical thinking. No, physics is something totally different. Physics helps you, enables you into critical thinking, observation and deduction, which becomes very, very important to take decisions, become entrepreneurs, and do various, I would primarily say, decision-making power, which makes you a better entrepreneur and enables you with great leadership qualities, which is required, I can tell you, at any portion of your life, not only as a teacher, not only as an entrepreneur, but even as a normal human being. How do you take decision? How do you take leadership? How do you solve a problem? And that is practical in our day-to-day life. All those points which I told today is basically meant to enable you, motivate you, enrich you, that this is physics all about. It is not about Newton, Einstein and string theory and quantum mechanics. It is something which enables you, empowers you, and gives you a kind of a capacity which will help you to solve problems, do critical thinking in every sphere of life on a day-to-day mode. Thank you for watching this video. My name is Shaunak and I'm signing off from today's video, promising you to be back with another important video. Till then, goodbye, and oh yes, don't forget to subscribe. Click on the notification bell and click on the all notification so that you get all the notification from Physics for Students.
Now, you can be a part of our team. You can send your scientific articles, essays, research papers, lesson plans on a particular subject of science. For further details, please write to us at editor@physicsforstudents.com. Stay safe and happy.